Hey drivers, today we're going to upgrade our engine stand to an engine test stand with the electrics necessary to run a VW engine right here on the engine stand. It'll have a nice complement of gauges and switches and indicators. I've also worked out a way to run generators with this regulator, OEM alternators with another regulator built in, and then finally the later aftermarket alternators that have an internal regulator of their own. We're not going to solve every problem, but we're going to try and cover as many bases as possible. Of course, we've already made our panels and drilled everything. This should be pretty cool. We have a base for our panel as well. We'll be mounting the regulator right there. Even made an articulating arm here for the panel to be mounted onto the stand, and complemented it with a nice tool tray that can be moved around to either side of the engine stand. We're really getting fancy here, but that's what happens when you have fun with fabrication equipment. So the next task is to get the panel fully assembled and ready for paint. We have some inner supports here. What I want to do is weld some washers in place so we have some nice locations to tie down the internal wiring. It's going to be kind of busy in there, and I want to keep things nice and tidy. So let's do some welding. Starting to get an idea on what it'll look like, and I like it. Need to load everything into it and start the wiring process, so we'll do that all on the bench, of course. But this cable arrangement is good. Got some holders for it along the way. This is the main harness that we would need anytime, and if we're involving the charging system, then this loom would also be necessary. Okay, let's get this thing on the bench, load it up with all of its devices, and see if we can wire it without making a big mess inside. On the back panel, I'm using some speak-on connectors. These are for power amplifiers and sound reinforcement speakers, so they can handle a decent amount of current. Each one of these is a 4-pole variety, and this one is an 8-pole variety. The way we've arranged this is so we can deal with a generator or an OEM alternator or an aftermarket alternator. We just plug the one cable into the corresponding connector. We'll be putting a mode switch here too that takes care of a couple of other details in the wiring. This is the main harness, a speak-on 8-pole connector. That'll always be necessary whether or not the generator or alternator is being involved in the engine test. Down here is a pass-through. This is an 1/8 inch NPT opening here. This way we can get a line over to the vacuum meter that'll be mounted in that location. We're using 3 fuses, one for the main, one for accessories, and one for ignition, or I don't know, might reverse those. Main power for the unit will come through these 1/4 inch battery posts that we'll mount here and here. We've just made up the main power cable here. It's a little weird because it's really busy. Probably the oddest part of the whole thing is a junction that we've made here to split it out for 3 spots. So let me show you what's going on. For starters, power comes in from the battery on this post and to the fuse. All of this needs to happen on the down side of the fuse. So we'll connect to the fuse here with this spade connector, and then it goes over to the battery terminal that's on the bottom of our ignition switch in there, and we have another wire coming off of that to pass across the unit all the way over here where the charge wires from generators and alternators are coming in. We'll pick the generator charge off of that terminal on the switch, so we have a ring terminal for that, and then the charge wire from the OEM alternator or an aftermarket alternator will be coming off of the top spade connector, and so we have one for each of those. So really the main part of this harness is how the battery will get charged while on the stand, and that first wire is power for the unit going over here to the ignition switch. I did choose to use an ignition switch. I obviously don't need a key for this. The advantage of using an ignition switch is you get a lot of stuff all built into one device. All right, we have the accessory switch, the ignition switch itself, and of course the momentary start feature. That takes care of a lot of things all in one spot, and I like that. Making some progress. I haven't tidied anything up. I'll do all the cable ties and all that stuff when all the wires are in. Gone ahead and wired up the ignition to the fuse and the accessory to the fuse and this starter wire. But this is a wire that I know at some point I'm just gonna stay on the starter trying to get an engine to start. Each pin of this NL8 connector should handle the 8 to 10 amps or so that'll be going to the starter. But what I've done is use 2 pins just to be sure, and I split this 12 gauge wire out to fit across 2 pins. Same thing with the cable, of course. We have made some progress. Truth be told, this took me a couple of days. I added significantly to the time that it took by making mistakes, which was kind of frustrating, but also a lot of redesigns, and that just kind of goes with the territory. But I feel like I've wired the thing twice. Still need to tidy things up, and I have one more wire to add in. This is the cinder wire for the oil temp. I'll come back and use these 1/4 inch washers that we have welded in place to tie everything down. That should make it look quite a bit more tidy. And I've been following the same routing, even if it could be done shorter. And that gives us a little bit of a service loop on each one of these, a little bit of extra room in case we need to move some things around or pull a connector out and change something. We'll know here in a few minutes if we'll be doing any of that in the short term. I hope I found all of the issues along the way, but we'll see. That's what testing is for. This is a lot of wire. A lot more wiring here than I really expected, but that's all right. It should get the job done. We have our fuses in place, very important. 20 amp for the main, a 10 amp for ignition, and a 5 amp for accessory. I just guesstimated at those. We'll see how it goes. The way I look at it is the fuses are there to protect the wire, and the wires involved in those circuits, for the most part, with exceptions, should withstand that kind of current flow for at least a short amount of time. This is our mode switch. All the way up is generator, and we'll plug our 4-pin connector in there, because that's what we're dealing with now. Middle position is a 2-wire alternator. That's like the aftermarket variety that I think most of us are familiar with. And then in the bottom would be an OEM alternator. I'd still need to add the external regulator that was used with those models, and I'll add the wires here once we're done testing. But we should be able to start any of those configurations. Today we're running a generator. This is for the vacuum line. In fact, I'll get this uncoiled and set up, but this is some legit 1/8" vacuum line. We'll go ahead and put the barb fitting in here. This is just a bulkhead fitting. It's made for passing through a panel like this, and there's another one of these on the inside with a short line of vacuum hose that goes to, of course, the port on the vacuum gauge. I used thread sealant on both of those fittings. I probably don't need to here. We're not talking about a ton of vacuum. Mid-20s is about as high as I expect to see. Go ahead and connect our 8-pin. This is all this stuff. This is the starter that occupies 2 pins on the cable. The coil, there's an extra line that I've added for a future upgrade, and then all of the senders. So a tack sender, an oil temp sender, an oil pressure for the idiot light wire, an oil pressure for the gauge, and something else. Oh, the generator light. Nope, that's on the other stuff. I don't know. There's another thing. Actually, that's all of it. So yeah, starter wire, coil wire, a future upgrade, an oil temp sender, a tack sender, and oil pressure and pressure for the light and the gauge. And that's 7 conductors, one of them occupying 2 pins. Okay, all right, we're good there. Let's get the vacuum line on and try it out. We have our coil. This is a wire for a future upgrade, and it has its own switch here. Tack wire on the negative side of the coil. The blue and green is the oil pressure light. The blue and yellow is the oil pressure gauge. Over here, blue and white is the oil temp. Here we have the charge wire. In this one, it's labeled D+. Elsewhere, it's labeled B+. This is our field wire, here labeled DF. And I like to run the ground wire. Oftentimes, like on trailers and stuff, this will be color-coded white. But here, it's color-coded brown. This is a wire that would be used on the OEM alternator. Of course, we have the starter wire. This will be the hardest working wire out of all of them. Here's our vacuum line to the manifold. Okay, let's hook up the battery and then we'll do fuel. We have our hot on the solenoid per the usual. We've grounded on the transaxle down here on the bottom of our engine start dilly-doo. Nice tidy cables all the way down to the battery, and we'll finally hook up ground. Let's go this way with it. I have my trickle charger turned off at the power strip right now, but I'm going to go ahead and put the alligator clips in place. We'll be putting it back on the charger a little later. I have it turned off not because it would make any difference, except on my voltage readings. With the trickle charger on, I should see 14 volts, and that would obscure any issue with the charging circuit. Of course, we're connected here, our vacuum line, our two speak-on connectors. Yeah, now we need to do fuel. I have not added fuel to the tank. I just want to make sure that the panel's basic functions work. Then we can try that out. Plus, we don't want to run the engine very long because there's no exhaust on it. It's going to be really, really noisy. Really just want to test things, so we'll keep that brief. Alright, this ignition switch is like a dune buggy style, where to the left is accessory. That looks good. Really the only things that should come on is the indicator light and the backlights for these 3 gauges and the tach, which it looks like it's on. We're using the bulb here to excite the regulator. So this bulb is in parallel with the gen light, and they should work in tandem. Okay, this is ignition, and this is our future upgrade. So we won't worry about this one today. This should not come on. Now if I go over to ignition, now we get our cinders involved. And it looks like the backlight is on, so that's good. I can turn on ignition and we're going to listen for a click at the solenoid in the carburetor. Yeah, I can hear it and feel it. So that's cool. I'm going to turn ignition off and see if we can build oil pressure. Whoa. The starter did not engage correctly. And now we're out. We may have a dead battery. That'd be great. Yeah, that has a very bad look to it. We're going to try and limp through this. I have a battery charger with a 75 amp starter function on it. Not a great idea, but we'll try it. Ignition is off, really just looking to build oil pressure. Our battery is hurting. Okay, there it is. So our oil pressure gauge is working, and we're building a little pressure. I'll take it. Our light went out. Okay, before we burn up the starter, let's put some fuel in it and see if we can get the gen light to come off. Okay, just enough fuel showing on the meter for our intentions, and I don't see any leaks. We want to actually start the engine this time, so we need to turn the ignition on. Set the choke, give it a whirl. No exhaust, so it's going to be noisy. I forgot to turn the fuel on. Looks like it's pumping fuel. We'll get there. There's fuel in the bowl. Well, I don't need to go crazy with that. Kill switch. And this light was flickering while it was running, but this is a really low current LED, so a bright light is what we're looking for there. Okay, I'm happy with that. We were charging, we made oil pressure, and it showed on the meter. We didn't run long enough to really register temp, and that's okay, I'm gonna trust it. And our vacuum showed up nominal, so that's good. All right, I think everything works. We'll finish up a few more wires, then we'll be all set. These engines sound like the Jetson Mobile when they don't have the exhaust. But I'm happy. We have a lid for this thing, so it'll be cool. But I'm happy it passed the test. We need to finish up some things, and then we can move on to actually working on the engine. We have all of our wires done. We've put in all of our cable ties. Still looks pretty crazy to me, but we'll go with it. Gonna put a lid on this beast. So there we are, the toolbox sized engine start box, fully connectorized, so there's never any cables hanging out of it. That's kind of nice. With tach, oil pressure light, voltage, generator light, a vacuum gauge, and oil temperature. This is going to be very handy for us. This is where we'll put it when we're running in an engine, and then we'll stow it back there for all other times. Check out this video to see how we built this stand that can pick up the engine off the ground. And stay tuned for more additions to our growing shop. Until then, keep the project alive and drive the dream.